we apply the rated voltage to the LV side, and then with open the HV side. So the entire no load loss test will ever happen, and through our meter, 2-watt meter method, or our power analyzer. If previously we used 2-watt meter method, but right now we are using the power analyzer, and we come to know that what is the no load loss. In case of full load loss, while we are doing the full load loss test, we usually apply the voltage to the HV side, keeping short circuited all the connections of the LV side. We put the voltage to the HV side in such a manner that the full load of the short circuit period of the HV side can be attained. The moment this full load is attained, we measure it through an ammeter. This full load is attained through that ammeter. We see, we stop that voltage, and the load is being tested. I think the test is being done. That in that manner, we full load loss and no load loss usually do. Then we come to the introduced over voltage withstand test, that is DVDSP, double voltage, double frequency test. Is a very important test. It usually do for inter-turn insulation test, whether the inter-turn insulation is proper or not, or we want to see that core can withstand the withstandable capacity. Core has got that withstandable capacity against the double voltage and double frequency. In that particular case, what we do, we put double voltage of 11 kV, that means 22 kV from 11 kV side, and double frequency, that means 100 hertz parallelly. Why? As we know from electrical, I think basic theory, that V by F ratio should always be constant in that electrical instrument, in this transformer. So when we double the voltage, or frequency should be doubled. So double voltage, double frequency put in that manner. But through the machine, when we usually do, see, the frequency can be doubled by two manners, either by changing the speed or by changing the pole. So what we do, we double the pole numbers in that particular machine. There is a selected, there is a possibilities we can set the pole number, and by choosing the pole number, doubling it, we can create the double frequency for that particular current which is being fed, for that particular voltage which is being fed to the transformer, and thus we can understand whether this particular transformer is being able to withstand the core and the inter-turn insulation, even double voltage, double frequency. So this is a little bit of circuit diagram of that. This is the motor generator set, and thus we do the double voltage, double frequency LP side, keeping HV side open. Now the measurement of voltage ratio. Voltage ratio, I have told you that in case of V1 by V2 and N1 by N2, when we measure N1 by N2, that is the turn ratio. Now obviously the our turn ratio should be always 5.19. So by measuring that, we can make sure that the voltage ratio is always in the right manner for that transformer. And test verifies, as initially I have explained to the vector diagram, that the DY11 vector group test usually do that by doing the ratio measurement of RY by RN, YB by YN, and BR by BN. If the ratio is same, we see the vector group is same. Then a separate source voltage withstand test. It is a very good, important test. This test checks the insulation property between the primary, I mean HV to R, secondary to R, then LV to R, and so to secondary. What we do over here, LV winding connected together on R, HV winding connected together, and giving 28 kV for 1 minute. Same we do for the LV test, but we do the 3 kV for 1 minute, and it is equipment use a high voltage tester, and this particularly gives us an idea about the insulation leakage current. This is the circuitry of the LV and HDI high voltage system, how we do that. Because of shortage of time, I don't want to explain it much more. 30 degree VCB is there. It is how it is placed in a Marcelin box. Am I audible? Everybody, to everybody?
You are audible, sir. Yes, sir.
Thank you so much. Thank you so much. Now you see the rated voltage 33 kV, highest voltage 36 kV. And now I just want to do two things: breaking capacity and the making capacity. What is the breaking capacity of the 33 kV? At the current 25 kVA, 25 kVA, that's the maximum withstandable current for this VCB. When 25 kVA short circuit or fault current flows through this for 3 seconds, so it will be breaking. That means it splits the entire connections and it will be off positions. But the making capacity, what is the making capacity of the you see the making capacity is much greater than the breaking capacity of a VCB. What is the making capacity? Making capacity is the maximum current that breaker can conduct at any instant of closing. Why? It is considered as the peak value of the first cycle when there is an imaginary short circuit between the phase. Suppose you see that there is a short circuit between the phase. In that particular case, whatever the current flows, that also can be withstand by this VCB system. That is called the making capacity. That is a standard parameter. Obviously, short circuit current 3 second withstandable is 25 kA kilo ampere, and insulation level is, as I told earlier, 30 kV, 70 kV, and 160 kV pulse. Now I will go for the gravel spreading. You see a substation which is very shabby look, where is naked earth on the left side, and the right side is a transformer with the gravel, and the very in sober manner it is being placed. Why the gravel is being placed and what is the utility of it, I will explain it when I will talking to the earthing. Now I will come to the 11 kV switchboard system. Previously we have the oil circuit breaker. It was very bulky and shabby, but we have already replaced it through very slick type and very usable VCB, vacuum switch gear. So in that case, this portion is called the make break switch happen. Make break, any making breaking happens in this portion, the lower portion of this switchboard or switch gear. Middle portion bar and all the meters and control system is placed over here, and the top portion is placed through a meter. All the meters are over there. So all that is looked after through this. The annunciator circuit, the meter, the programming protection system, these are all the protection systems. These are the protection systems in any switch gears, and these are the control we can do. And the below portion you see, these are the mechanical portion where makes breaks happen, and with the vacuum quenching medium is the vacuum gas, basically gas. SF6 gas we usually use over it. So this is the difference. We replace all these MOCB to the slick one, and this is the 11 kV bus bar arrangement. We usually use the 1200 ampere bus bar. Previously we used to use 800 ampere bus bar, but that has been replaced by 1200 ampere bus bar. Okay, now this is the CT, that is the back side of the 11 kV switchboard where CTing is placed, and this is the secondary terminal of CT, the secondary terminal, and you see the watts usually emanated through this secondary terminal and went to the relay system, and through relay system it is going to the trip coil. That is the 11 kV CT, and this is 11 kV VCB, the vacuum circuit breaker. This is the vacuum interrupter acting as a quenching medium and make this happen, and arcing and the heat generates during making and breaking. And these are the male contact. This is a male contact, and these are the chamber where the entire portion of the make breaking system placed. This is the basically spout, and this is 30 kV CR panel, control panel. 30 kV, all the controls, CT, VCB, and all the controls is being done over here. And this is switchgear painting we usually do for avoid erosions, restrict erosions, and everything. This is the structure where the bus bar, this is the pipe bus bar you see, and these are the insulating support as well as the isolator, and the VCB is in place. These are the switchgear PTR. There is a panoramic view of those substations. I don't want to. This is also another panoramic view of substation. This is the PTR installation arrangement. These are the plinth. You see, we usually 6.3 MVA transformer and 10 MVA transformer usually use the same plinth. It is 3.3125 by 3125 millimeter, and these legs are all 0.6 meter to each, and usually placed over it for 6.3 and 10 MVA, the same plinth size. And these are the 11 kV switchgear arrangement. As I've told you earlier, these are the 11 kV cable laying arrangement. We usually do from the 11 kV switchgear, all the 11 kV cable which comes out from the 11 kV switchgear and is lays into the cable laying arrangement of the switchyard. This is called tunnel of the cable, and it is already being placed through a rack by iron channel. We prepare the rack, and through rack this cable is being laid, and then this cable is run through the end of the substations, and these are the substations where the 11 kV structure is being placed, where from the 11 kV Bayard conductor runs through. You see the circular portion of this thing. This is the extra portion of the cable which is being kept. If for latter portion of the period, maybe 1 year or 2 years down the line, if some fault happens and this cable may be cut and again rejoined, so then some portion, extra portion is needed, and that's why this extra portion is being kept through a round shape civil structure. And if it is not there, then entire cable may be changed, and that I think brings so many cost involvement to bring a little bit of portion of cable to, in spite of repairing the little bit of portion of cable, we have to replace the entire cable. That is not possible for commercial point of view. That's why we use some extra portion of cable and kept in such a manner. And this is the outgoing portion of the 11 kV. This is the DP structure, double pole structure, and from where the Bayard conductor of 11 kV feeder is being drawn, you see there. And this is the bus bar structure. Why this bus arrangement we do sometimes? If some faults happen in the cable portions, and maybe it is very essential to cater the power to some demography, so we do from another cable we charge the bus, and from that bus we do in such an arrangement that this portion of the feeder is being fed through that bus arrangement. That's why this bus arrangement is being done. But basically what happens, some bar fault is being done, has happened,